On a quiet July night in 2025, astronomers in Chile noticed a faint dot moving slowly against the background of stars. At first, it seemed ordinary, just another object drifting near Jupiter's orbit. But as they tracked its path, the dot began to tell a different story. It was moving too fast, too freely, on a trajectory that didn't fit any known comet or asteroid from our solar system. Within hours, the realization set in. This wasn't ours. It was an interstellar traveler, only the third ever detected in human history. They named it Comet 3IATLAS, a frozen visitor from the stars. On July 1st, 2025, the Atlas Survey telescope in Chile officially logged the object. It was about 4.5 astronomical units from the Sun, roughly 670 million kilometers away, just beyond Jupiter. Its velocity was staggering, over 200,000 kilometers per hour, about 60 times faster than a bullet. At that speed, nothing could hold it in orbit. The Sun's gravity wasn't strong enough. This was a hyperbolic orbit, the mathematical signature of something just passing through. The International Astronomical Union moved quickly. Within hours, it was formally designated 3IATLAS, the third interstellar object after Oumuamua in 2017 and Borisov in 2019. But discovery was only the beginning. The very next day, telescopes noticed a faint coma forming around the object. This meant 3IATLAS was not an inert rock, like Oumuamua appeared to be, but an active comet. Even at the distance of Jupiter, sunlight was heating its icy surface enough to trigger sublimation, the direct transition from solid ice to gas. That gas carried dust with it, creating a hazy halo and even a short tail. For astronomers, this was astonishing. It meant the comet carried volatile ices that had survived billions of years in interstellar space, untouched since the day they formed around a distant star. And now, under our sun's light, those alien ices were evaporating for us to study. Imagine it, vapor from another star system, streaming past our telescopes. At first, the comet's brightness suggested it might be enormous, perhaps 20 to 50 kilometers across, larger than many solar system comets. That would have made it the biggest interstellar object ever observed. But the glow was misleading. Much of the light was from the coma, not the nucleus. As astronomers refined their measurements, especially with the Hubble Space Telescope, they found the solid core was far smaller, likely no larger than 5.6 kilometers, and possibly as small as 0.3 to 1 kilometer across. To put that into perspective, the nucleus could be the size of Central Park or smaller. Yet even this modest snowball was incredibly active, already venting dust and gas while still billions of kilometers from the Sun. That level of activity placed it closer in spirit to Borisov, the icy comet of 2019, than to the silent mystery of Oumuamua. But 3IATLAS still held secrets of its own. What was this comet made of? Using the James Webb Space Telescope and ground-based observatories, scientists analyzed the gases in its coma. They found familiar ingredients: water vapor, carbon monoxide, carbon dioxide, and carbonyl sulfide, molecules commonly found in solar system comets. But one ratio shocked astronomers. The comet's coma contained about 8 times more carbon dioxide than water, an unprecedented CO2 to water ratio. This was one of the highest ever measured in any comet. Such a composition suggests 3IATLAS formed in a colder environment than most solar system comets, possibly in the distant outskirts of a planetary system or around a red dwarf star, where CO2 ice can accumulate in huge amounts. In other words, while the ingredients were familiar, the recipe was unique. The comet was telling us, yes, star systems everywhere make comets, but not all in the same way. To understand 3IATLAS, we compare it with its predecessors. Oumuamua, 2017. A cigar or pancake-shaped rock, no coma, no tail, yet it mysteriously accelerated as it left the Sun. Was it exotic ice? Or, as some speculated, even alien technology? 3I Borisov, 2019. A relief to astronomers. Bright, icy, textbook comet behavior. It confirmed that other star systems do produce familiar comets. 3IATLAS, 2025. Active like Borisov, but chemically peculiar, with an extraordinary CO2 abundance. Together, these three objects show us that interstellar visitors span a spectrum, from puzzling rocks to active, icy comets. Each one is a chapter in a growing story. Where did 3IATLAS come from? Its speed and orbit suggest it has been adrift for billions of years. Some models even place its age at over 7 billion years, older than our solar system itself. It may have been born in the outer regions of a young planetary system, only to be ejected by the gravity of a giant planet or a passing star. Since then, it has wandered the galaxy, through nebulae, radiation fields, and stellar winds. Its surface slowly weathered by cosmic rays, and yet, deep within, it preserved the chemistry of the place it came from, a frozen memory of a world we will never see. On October 30th, 2025, 3IATLAS reached Perihelion, its closest approach to the Sun, about 1.4 astronomical units away, just inside Mars's orbit. But from Earth's perspective, it was hidden behind the Sun. By early December, it reappeared briefly, allowing telescopes one last chance to study it before it faded. By early 2026, it had grown too faint to observe, vanishing forever into the dark between stars. But the data it left behind was priceless. It proved that comets from other stars can look like our own. It supported theories of planet formation across the galaxy. And it reminded us that our solar system is not alone in sending icy messengers into the void. 3 interstellar objects in less than a decade. That's no coincidence, it's a sign of our improving technology. The Vera C. Rubin Observatory, with its massive 3.2 gigapixel camera, will soon scan the sky every few nights. Astronomers expect it to discover dozens of interstellar objects every decade. Some may even be spotted before they enter the solar system. That opens the door to something extraordinary, an interstellar intercept mission. The ESA Comet Interceptor, launching in 2029, will wait in space for the chance to chase down a pristine comet, or perhaps an ISO like 3IATLAS. Imagine a spacecraft flying alongside a comet from another star, sampling its gases directly. Science fiction? Not for long. 3IATLAS may have been small, a frozen chunk of dust and ice, but it carried with it the story of a world we will never see. For a brief window in 2025, it passed through our skies, offering us a glimpse of the galaxy beyond. It reminds us that space is not empty. It is filled with stories, some told by stars, others by comets. And the next messenger from the stars may already be on its way. Stay curious, stay watching, and subscribe for more wonders from beyond.